All right, so this is AP Calculus. We're doing Unit 4 pretest. Number 1, an equation of the line tangent to the graph at this equation at this point, 1, 5, is what? So the way that we start number 1, I'm just going to switch to blue here. It's not necessarily key. I need to write down my general equation. I'm going to do it up here. Y minus blank is equal to blank times x minus blank. I know I'm using this equation because it says equation of the line tangent. That tells me I'm needing an equation to the line tangent. In point slope form, I just taught that in Algebra 1 today. It was majestical. So from here we need to plug in what we have. We have the x-coordinate of 1, we have the y-coordinate of 5. So the x-coordinate is 1, the y-coordinate is 5, and then we need to find the slope here. So the slope, when I plug in 1, I need to take the derivative and plug in 1. I have a quotient, which means I'm using what rule? Quotient rule. All right, so quotient rule is low d high minus high d low all over low. So from there we know that our low is going to be 3x minus 2. The derivative of the top is 2. I'm going to subtract high, which is 2x plus 3, and then low is 3x minus 2. All of that is divided by low, which is 3x minus 2 quantity squared. All right, and then immediately plug in as soon as possible. We know that x is 1 in this case. So 3 times 1 is 3, minus 2 is 1, so it's going to be 1 times 2 minus, and then 2 times 1 is 2, plus 3 is 5, times 3 times 1 is 3, minus 2 is 1. All of this divided by 3 times 1 is 3, minus 2 is 1, 1 squared, 1 quantity squared, and that is equal to 2 minus 5, so that's negative 3. Have I made some giant mistake here somewhere? I think that's fine. Again, I should print out the key in front of me. All these forms are in standard form, so I need to convert over. Once I convert to standard form, notice that standard form, everything is an integer, a whole number. So I'm going to distribute. I get y is equal to negative 3x plus 3, and then I need to add on that 5 over here. It was a negative 5, I added the 5. So from there, I need to add the 3x over, so I now have, let's switch to black here, y, I guess I should say 3x plus y is equal to 8. And can I convert any of these forms into that? 3x plus y is equal to 8? Uh-oh. What mistake have I done? Usually it's a slope mistake. I'm guessing my mistake was somewhere here or here because I'm not getting these answers, and none of them can be reduced any farther. Yikes, what did I make a mistake on? Alright, well, it's an extra credit point if you can find it. 3x is to low d high minus high. I see it. Oops, I feel very silly, but there it is. Who can find it? Go, you got this. It happened right here somewhere.
The dinner of the derivative of y. Wait.
No, it's not
Where did
dinner.
that come from? I'm so confused.
Because if you plug in 1
Yeah,
right there.
Stego has it. This should just be 3.
Oh, woo! There you go.
Alright, so this 1 changes into a 3, so I can come back here. That 1 changes to a 3, which means it's 2 minus 15. 2 minus 15 is negative 13. That's looking way more familiar. Minus 13, so I come up here. Let's do this. Minus 13 here. I think I can just squeeze it in here. It's not very neat. Minus 13, so it's minus 13x here, which is positive 13. 13x plus y. 13x plus y. There it is. Oh wait, we were messing up still. Oh, because I need to distribute this. This becomes a positive 13 here. Positive 13 plus 5 is positive 18. And finally we get B is our answer. Yeah, make sure you take the derivative when I'm doing d low. It's not low, it's d low. That was my bad. All right, number 2. We're looking for the equation of a line tangent. Equation of a line tangent means it's going to be y minus box is equal to box times x minus box. So we have x is equal to -1, so I can plug that in here. That's x from -1. I need to plug in -1 into y to figure out what that is, so I can say that's going to be 4 times -1 cubed minus 5 times -1 plus 3. I can say that's my y. So my y is equal to, it's going to be -4 plus 5 plus 3, which is +4. So I can plug in my 4 here. Next up, I need to take the derivative and plug in -1 to find the slope here. So when I take the derivative, I can say this is f prime of x is equal to 12x squared minus 5, plugging in -1. So f prime of -1 gives me 12 minus 5, which is just equal to 7. I went kind of fast there, but I think you guys can all assume that -1 times -1 is 1, and 1 times 12 is 12. That's how I got that 12 right here. So I'm filling in my 7, and then I need to simplify. So simplifying down here, let me do this in red, I guess. Coming down here, that's going to be y is equal to 7x. Again, these are going to become positive, so 7x plus 7, and I need to add on that 4 over, so plus 4, and you see that 7 plus 4 is 11. Correct answer is C.
7 plus 4 is 11.
It is indeed. I think that's where a lot of people have made their mistake in this final step here. On to number 3. If you want to throw on the brakes, just raise your hand, ask a question, or just throw up your hand and be like, just give me 2 seconds. Number 3, for this function, what is the approximation of f of 0.1 using the line of the tangent to the graph? So again, do the same thing. Y minus blank is equal to blank, our box, times x minus box. And we have all the information essentially. You just need to plug it in. So we know that our x is 0, our y is 1, so our x is 0, our y is 1. So whatever's inside the parentheses here is 0, or is x, so x is 0, x is 0. So if that is the mistake that you made, then that's really easy to fix on the next one, right? Then we need to figure out what the derivative is. It tells us the derivative. I need to plug in the derivative, or plug in 0.
Oh, you got y when f of 0 equals to 1, right?
Yeah, so that's where x and y both come from. And it tells us x again, kind of pointlessly. Oh, I guess it needs to match up this and this. But anyway, we need to plug in. Let's come down here. We're going to say, what is f prime of 0? Plugging in x is equal to 0, and that's going to be 3 times 0 minus 2, which is just -2. So -2. And then finally, I need to plug in 0.1 to actually get an approximation. Here we go. So it's going to be y minus 1 is equal to -2 times the quantity of just 0.1, or 0.1. So -2 times 0.1, that's going to be -0.2, and then I need to add 1. So coming over here, we have y is equal to -0.2 plus 1, which is equal to 0.8. Correct answer C. All right. Moving on to number 4, and I do feel bad for going fast because I know a lot of you are still kind of struggling on this one. Oh yeah, I was supposed to take a picture of Stego. Stego, did you finish your pretest? I'll take a picture right after we finish this. All right, number 4. We have another equation to the line tangent to the graph. So you're doing the same thing yet again. Y minus box is equal to box times x minus box. We know that our first x-coordinate is pi over 4, so pi over 4 goes in that first box. We also know that we need to plug in pi over 4 into this equation right here to figure out what y is. So let's do that now. Y is equal to cosine of 2 times pi over 4. And that's going to be cosine of pi over 2, and in pre-calculus we've been practicing this over and over and over again. Cosine of pi over 2 looks like this. If I'm making my graph, pi over 2 is straight up, cosine is the x-coordinate, x-coordinate here is 0. That makes me feel like these Did I mess up somehow? Cosine
Isn't that 90?
of pi over 2 is 90 degrees, yes.
So it's 0.
It is 0, which is weird here because, oh, that's the y-coordinate. I think that was the slope. Okay, I was hung up there. Yes, it is 0. And then we need to find the slope, so we need to take the derivative. Taking the derivative, we have y prime, derivative of cosine of 2x, cosine changes to sine. C stands for change, so change it to a negative, so negative sine of 2x, and don't forget your dinner, times 2. And then we need to plug in pi over 2 yet again. So now y prime is equal to, what's up, Gio?
So when you did the first of the cosine, you
Yep.
didn't take the derivative, right?
Exactly. We don't take the derivative because we're just trying to find the y-coordinate. The y-coordinate here is just plugging in.
That's a y coordinate.
So we plug in pi over 4 for y prime to figure out what the slope is right here. And again, we're still looking at the same coordinate at pi over 2 because 2 times pi over 4 is pi over 2. And the sine is the height. The height here is 1 because on the unit circle. So this is going to be, this evaluates right here. Everything in the circle is 1. But there's also a negative here, so negative 1, and negative 1 times 2 is a negative 2. This is a negative 2. So come back over here, say that's a negative 2, and y is equal to negative 2x minus 4, so it looks like the correct answer is E. X minus pi over 4. People are still writing, so that's why I'm waiting, and we are on to number 5. Finally, a related rate problem. So let's analyze the notation. Volume is increasing. So I immediately say V prime is going to be something positive. Volume is increasing at a rate of 12 cubic feet per minute. Perfect. When the volume is, 36 pi, we're looking for how fast. So I'm talking about some derivative because I'm talking about speed. So what is the prime of the surface area? So what is S prime? That's what it's looking for. And it tells us our formulas here. If I have V prime and S prime, I'm going to be taking the derivatives. So really quickly, if I take V prime, the derivative of V, the 3 is going to come down in front, and the 3 and 3 are going to cancel out on the top and bottom. So I'm left with just 4 pi r squared, and don't forget your dinner, r prime. And finding the derivative of surface area prime is equal to 8 pi r prime. And perfect, so we have the derivatives. Now we need to plug in what we know. So we know V prime is positive 12, so I can come over here and say this is a positive 12 is equal to 4 pi. We don't know r, but we don't know any of this stuff quite yet. Let's jump over to S prime then. S prime, we don't know S prime. That's what we're going to be searching for. We don't know R or R prime, so we're stuck again. So let's go back to our original equations. We have 4 equations to deal with. It's one of those 4, right? We can't use V prime, we can't use S prime, let's use V or S. Oh, well, if it gave us V, that's probably going to be our answer here. So if I come down here, we know that V is equal to 4 pi r to the power of 3 all over 3. And I know what V is. V is 36 pi, so I can actually change it out to a 36 pi. All right, let's divide the left and right by pi. Yoink, yoink, gone. Let's go ahead and divide both sides by 4. So if I divide the right-hand side by 4, the 4 disappears. 36 divided by 4 is 9. So now I have the equation 9 is equal to r to the power of 3 over 3. Now I'm going to multiply both sides by 3. So when I multiply both sides by 3, I get, multiply both sides by 3, so I get 20, I'll move up here. This is now 27 is equal to r to the power of 3, and then finally cube rooting both sides gives me r is equal to 3, which is nice now because I can plug in r. Interesting. So we're going to have an equation that gives us an r prime now, right? So r is 3, so this is going to be up here, 3 quantity squared r prime. The only unknown now is r prime, and once we figure out r prime, we'll have r prime and r, so we can find s prime. So here we go. We're going to solve. I'm going to divide both sides by 4 and both sides. Oh, I can't do that. I'm going to divide both sides by 4 right off the bat, and I'm going to get the equation. I'll switch back here to yellow. 3 is equal to 9 pi r prime. So far so good. And let's divide both sides by 9 pi. So I'm going to get 1 over 3 pi is equal to r prime. So let's plug everything in. So we have now s prime, which we're trying to find, is equal to 8 pi times r. R is 3. Times r prime, and r prime is 1 over 3 pi. 1 over 3 pi. Lots and lots of things are going to cancel out. Pi on the top, pi on the bottom. 3 on the top, 3 on the bottom. S prime, therefore, is equal to 8. Correct answer is A. All right. Questions? Geo questions? Still writing it down. Doesn't even have time to think. Then, if there are no questions, we're going to move on to number 6. So we have the radius of a circle is increasing. At a certain instant, the rate of the increase of area, so it's talking about area prime here, so let me write it down. It's saying that area prime is numerically equal to twice the rate of the increase of its circumference, so 2 times c prime. And what is the radius at this instant? We know it's 2 because we've seen this problem before, but let's talk about why. So I know that just normal area formula is pi r squared. I know that the normal circumference formula is 2 pi r. If I take the derivative of these, a prime is equal to 2 pi r r prime. When I take the derivative of circumference, circumference prime is equal to 2 pi r prime. So notice that area is circumference, but you multiply by an additional r. That's the only extra that it has. So another way of rewriting this area formula, or a prime formula, is a prime is equal to circumference prime, but you just need to add on an r, or multiply by an r. So if I use this and substitute it into the blue equation that we got from reading the text, we get a prime is now switched out to c prime r, and on the right hand side nothing changes, equal to 2c prime. Let's divide the left hand side and the right hand side by c prime, and r is equal to 2. Again, that was just one from the fix-up, so it should have sounded kind of familiar. And then we're moving on to question 7, which is a review from Unit 2. No, Unit 1. This is doing limits. All right, so we need to find where the limit from the left and the right both have a height of 1. Height of 1. All right, so we're checking mainly 3 points. This point, and this point. Those all have a height of 1. I know that because if I draw a line through a height of 1, it goes through that point. So from the left and the right. From the left, I have a height of 1. From the right, I have a height of a half. So it's not this one, because the double-sided limit needs to be the same height of 1. From the left and from the right, I have a height of 1, so this one is definitely an answer. 0 is an answer. Checking this one. As I go from the left, I have a height of 1. As I go to the right, I have a height of 1, which means that is also an answer even though it's a whole. Again, it's not checking if it's continuous, it's just checking that it's a whole. So the answer here is -2 and 0. -2 and 0, the correct answer is C. All right, we're on to number 8, mean value theorem. Immediately, I'm going to be thinking about my formula, and that is exactly what I'm going to be using because it's asking for some numerical answer. We can find the x-coordinate by using the formula. Formula again, shout it out, you guys know this. Exactly, all over b minus a. And I'm going to say and these are all x-coordinates, by the way. This whole formula is just the x-coordinates. If you don't know that, you can write it down for your notes. So my x-coordinate starts at 0, so that's going to be my a. And my x-coordinate over here is b. So I'm going to go between 0 and 4. And I know what my y-coordinate is because these y-coordinates are the y-coordinates corresponding to the x values. So if I come back over here, my formula is really straightforward. I know my y is square root of x, so I just need to do y prime, and then I can just plug everything in. So before I even took the derivative, this is just x to the power of 1/2. After I take the derivative, this 1/2 comes down in front, and I have 1/2 x to the power of, and I subtract 1. 1/2 minus 1 is negative 1/2. And then I can turn that into 1 over 2 square root of x. So, filling into the formula. On the left-hand side, I have 1 over 2 square root of x, but it's a c instead of an x. So it's going to be 1 over 2 square root of c. And that's going to be equal to, f of b is the b coordinate, or the y coordinate of the b, so it's going to be 2, minus the y coordinate of the a, which is 0, all over b minus a, so 4 minus 0. 4 minus 0. All right, and then you just need to solve this thing. So I now have the equation. I'll work in this space right here. So I now have 1 over 2 square root of c is equal to 1 over 2. Technically, you cross multiply and solve. So cross multiply, I get 2 is now equal to, cross multiply that way, I get 2 square root of c. Divide both sides by 2, and I get square root of c is equal to 1. Square both sides, 1 squared is 1. 1 is equal to c. All right, so which of these has an x-coordinate of 1? Looks like b. You can actually, they might have tricked you, though I don't think they would ever do this, but maybe they did 1, 2, and then you have to check, okay, if I plug in the x-coordinate of 1 into my equation, what is my y-coordinate? Well, if I plug in 1, square root of 1 is 1, so the y-coordinate is also 1. So that does make sense. Correct answer is B. On to number 8. We have a right triangle related rate problem. So let's go ahead and say this is a right angle because it's a rectangle. We know it's a right angle. And it tells us that z prime up here, I'll write it a little bit down here, z prime is 1. And it tells me that x prime, do I have enough room underneath here? X prime is equal to 3y prime. So this x prime down here is 3y prime. And I know that my x is equal to 4, so I can come up here, x is equal to 4, my y is equal to 3, and this is a Pythagorean triple, so 3, 4 was the length of z? 3, 4,
6.
you should know these,
5.
3, 4, 5. Again, Pythagorean triples that you need to have memorized because it just speeds up your calculations. 3, 4, 5 is the first one that you should have memorized. Then if I double that, 6, 8, 10, just doubling all the numbers, and then the other one that you have to have memorized is 5, 12, 13. I've never seen a Pythagorean triple on the AP Calculus test that was not in that list. They really speed up your calculation time when you're doing special right triangles. Or not special right triangles, just right triangles. All right, I guess if I just write my y prime over here, y prime is just equal to y prime. I don't know what that is. I'm looking for x prime. X prime is the question. So what is x prime? So let's set up our formula. We have, in general, we have a prime, or I guess in this case, y.
Why do we have x prime? Yeah, but x prime has a y in it. So then what's y?
Exactly, we'll figure it out, right? Once we figure out y prime, then we plug it back in, we'll find x prime.
Yeah.
So y prime plus x prime, I guess I could have switched those, is equal to z prime. And then we just fill in what we have, because we've used 100% of the information given to us in the problem. Let's just plug it in. So y is 3. Y prime we don't know. We'll just leave it y prime. Plus x we know is 4. X prime we know is 3y prime. So 3y prime. We know z is 5 and z prime is 1. So we filled in everything that we have. 3 times 4 is 12. So I have 12y prime here. 3y prime. 3 plus 12 is 15. So I have 15. Y prime is equal to 5. Therefore, y prime is equal to what?
3.
1/3. Yeah, so I divide both sides by 15. 5 divided by 15 reduces to 1/3. So that's not the answer, though. Look, they try to trick you. The answer is not 1/3 because I'm not asking for y prime. I'm looking for x prime. So now I need to plug it back in to x prime. X prime is equal to 3 times whatever y prime was. So x prime is equal to 1. Correct answer B. All right, number 10. We're taking the derivative twice. So here we go. If I take the first derivative, c stands for change, so I'm going to change the sign. It's going to be -2, and then cosine always switches to sine. And x over 2, leave inner alone, but now we're going to take dinner. Derivative of x over 2, shout it out, is?
X -2.
Ooh, come on guys, you got this. Not x over 2. Derivative of x over 2. It's the same thing as saying 1/2 of x. If I take the derivative of 1/2 of x, I get just 1/2. Yeah. Whenever you take the derivative of a constant term, you just look at the coefficient.
Oh, so it's 2.
Just 1/2. The derivative of x over 2 is 1 over 2.
Oh.
So that was the first derivative. I can say this was y prime was equal to this thing, and then the second derivative, y double prime. So I guess, so if I simplify this, it's going to be equal to 1, so -2 and 1/2 simplifies to just negative sine of x over 2. So now that I simplified, now I can take the derivative and it makes it a little bit easier. So S stands for same sign, so it's still going to be a negative cosine of x over 2. And don't forget your dinner. What is your dinner, Stego? There it is, 1/2. So where's -1/2 cosine? -1/2 cosine, what am I doing here? -1/2 cosine x over 2, correct answer is E. On to number 11. A, this was taken from the last pretest. Which of the following could be a graph of f if the derivative, so the derivative is positive, the second derivative is negative. So first derivative on a graph of just the normal graph, first derivative is height, slope, or concavity.
Slope.
So it's saying it's a positive slope. And second derivative is, so it's concave down. So which of these graphs have a positive slope and are concave down? Positive slope, negative slope for C. This has a negative slope over here for D. All right, so it's between A, B, and E. Which of them are concave down? Well, that's concave up right here, so it's not A. And this is concave up right here for E, so the correct answer is B. B is concave down everywhere and has a positive slope everywhere. All right. If there are no questions, we're moving on to number 12. For what values of x is this function decreasing? Again, this is our unit 2. Is it unit 2? No, it's unit 3 speaking at us. Unit 2 is just all about derivatives. Unit 3 was analyzing the derivatives. So I need to define f decreasing. What is the definition of f decreasing? It's where f prime or f double prime. F prime is less than 0. All right, so I need to find f prime then. F prime of x is equal to, well, 0, then plus 15. So I have a 15 so far, plus 12x minus 3x squared. So let's factor this thing. I'm going to rearrange this really quickly before I factor it to make it a little bit easier. I have negative 3x. Ooh, we have a walkthrough coming up. Negative 3x squared plus 12x plus 15. So my leading coefficient needs to be positive whenever I do factoring. It needs to be positive, otherwise it will mess up my factoring. So my thing that I'm going to factor out is a negative 3. When I factor out a negative 3, I'm left with x squared. I'm going to change all the signs here because I factored out a negative. I'm going to have a negative 4x and a negative 5. Now I can do ninja star in my head. So this is now a negative 3. Leave that negative 3. I know that you want to divide away because you're going to set this thing equal to 0. But for now, leave it. I'm just factoring the general equation without setting it equal to anything. I now have x minus 5 and x plus 1 after doing my ninja star in my head. And now I can set this thing equal to 0, which means I have critical values at 5 and negative 1. So this is saying that x is equal to 5 at x is equal to negative 1. So make your number line. There it is. There's negative 1. There's 5. I know that it's going to switch signs in terms of the y value over this because this is power of 1, this is power of 1. So I just need to choose the easiest possible number to pick. What is the easiest number?
0.
I like 0. Yeah, 0 is pretty nice. So if I plug in 0, 0 minus 5 is negative. Negative 3 is negative. 0 plus 1 is
Positive.
negative times positive is a
Positive.
So it's going to positive switch sign to a negative switch sign to a negative. And it's looking for decreasing. So it's decreasing anything left of -1 and decreasing anything right of 5. So less than 1, right of 5. Less than -1, right of 5. Correct answer is D. All right, we're on to number 13. And another problem from the last pretest. We're looking for relative extrema and we're looking for inflection points. Relative extrema and inflection points. So you guys need to give me some definitions. F, relative extrema. What is that thing? It is indeed F prime sign change. You need to have that memorized. Most of you do. Change. What about FIP? Someone aside from Stego. She's got these down. I know her. Someone aside from Stego. F inflection point.
F double prime sign change.
F double prime sign change. All right. I'm given F prime right here. And it even says the derivative of F is shown above. So it has it in words, and the notation could have been a little bit clearer. It's a low quality picture, but whatever. This is the derivative, which means if I'm looking at the if I'm looking at the first derivative, am I looking for height, slope, or concavity? Height. If I'm looking at F prime and I'm looking at F prime, they match, so I'm looking at heights. What about on F double prime? F double prime on a graph of F prime is slope. Good job. So I'm looking for a height sign change. Where does the height go from a positive to a negative or vice versa? Right there, once. So height, one time. What about slope? How many times does the slope change? Well, it's negative, 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 0, but it still stays negative, 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 and only right here does it change from a negative slope to a positive slope. Just going to 0 is not enough. It needs to go from a negative to a positive, so slope one time. So we have one relative extremum. And what is that relative extremum? What did my height go from a positive to a negative, negative to a positive? It went from the left to the right, so it went from positive to negative. What is that, Gio? Positive to negative, is that max or min?
Max.
Yep, this is a max. So I have one time and it's a max, and I have one relative and extreme, or I have one IP. So where's one max, one inflection point? C. Because A is saying I have a minimum and a maximum. I only have one max. So the correct answer is C. All right, we're moving on to number 14. When I take the limit as x approaches 0, the first step is just plug it in. If I plug it in, I get 0 over 0, the indeterminate form. So you have 3 steps whenever you get 0 over 0, the indeterminate form, which is, there it is, factor, cancel, plug in. So if I factor, I'm going to factor out an x squared times 5x squared plus 8. On the bottom, I can factor out another x squared times 3x squared minus 16. So I factored. Next step is to cancel. Chunk, chunk. Next step is to plug in that 0. That was your original step. I guess it's step 0. Ooh, what happened there? So I plug in 0. That means this goes to 0. So this right here goes to 0. This right here goes to 0. And I'm left with 8 over negative 16, which reduces to negative 1/2. Again, I think this problem has been on the last 2 pretests. It might be on the next pretest also. All right, number 15. The slope of the line tangent. Okay, this is different. It's not the line. It's not the equation of the line tangent. It's just the slope of the line tangent. So if you start doing y minus box blah blah blah, you're doing too much work. I'm only looking for the slope of the line tangent, which means I'm just taking the derivative and I'm looking for y prime. What is y prime? That's what it's really asking for. That's kind of the hard part about each problem, is like, what is it really asking for? This one is asking, what is y prime? So I'm going to take the derivative. I'm going to immediately plug in x is equal to 3, y is equal to 2. So taking the derivative. 2 comes down in front. It becomes 6y. Don't forget your dinner, y prime. Minus 2 comes down in front. 2 times 2 is 4. X to the power of 1, and x prime is just 1. Equals. Derivative of 6 is 0. Good. Okay. This thing is the hard part. It is product rule. So I'm going to help you with product rule. It is 1d2 plus 2d1. You got it, Gio. 2d1 All right, so I'm going to assume, just because I made a mistake last time, that all of 1 is negative 2x. I'm not disregarding the negative because I might forget to distribute it later. I'm assuming that all of 1 is negative 2x and all of 2 is y. All right, so 1 is negative 2x. The derivative of 2, the derivative of y is y prime. All right, plus 2. 2 is y. And then d1 is, yeah, you got it, Geo, is negative 2 times negative 2. Okay, immediately plug in your values of x and y. Do it as soon as you can. It makes your problem so much easier. So I have now 6 times y, which is 2. 6 times 2, y prime, minus 4 times 3 is equal to negative 2 times 3 times y prime, plus 2 times negative 2. All right, and then coming back up here, 6 times 2 is 12y prime minus 12 is equal to negative 6y prime minus 4. Now I need to solve for y prime. I'm going to choose the left-hand side for my y primes to make them positive. So I have an 18y prime is equal to, I'm going to add 12 to both sides, and I get 8 on the right-hand side. Divide both sides by 18 and simplify my fraction. My y prime is equal to 4/9. Correct answer, B. Questions? All right, we're moving on to number 16. This one looks familiar. I don't know if it was on the last pretest or not. I have a feeling it was, but I'm not. It was? Okay.
Yeah, that's all I knew it.
Oh, nice. Okay. Well, there you go. Just good memory, right? So 1 over x is the same thing as x to the negative 1, just for reference. So derivative of e house is e house, or at least Daughter for e house is e house. So e to the 1 over x. I just did Daughter. Now I need to do dinner, the derivative of this x to the negative 1. Again, when I take the derivative, this negative 1 comes down in front. It becomes negative x, and then I go down a power to the negative 2. And I just need to simplify this now. So the answer should be negative. So that already eliminates c, d, and e, because I have a negative right here. And it needs to be divided by x squared. So the correct answer is A. On to number 17. Hey, this one looks familiar again. This one, the easiest way to solve it is, do I have a positive even, a negative even, a positive odd, or a negative odd? It's one of the 4 choices, right? What is this thing? This one is a positive even. It's even because both hands in, or the end behavior is both going up, yeah. So if I take the derivative of a positive even, because I'm looking for f prime now, if I take the derivative of a positive even, I should get a positive odd. Which of these are positive odd? That is a negative odd. You're always looking at your right hand to figure out if you're odd or even, right? Right hand is down, so it's negative. So it's not A. This is a negative even. This is a positive even. This is, I don't even know, some weird function. The correct answer is E. All right, I'll finish recording 18, 19, and 20. I'll put the video up online. Study, study, study hard. All right, so on to number 18, we have this thing, and we need to find this thing. Okay, so it's already given us a y prime right here. Again, this can be converted to a y prime. I'm going to go ahead and isolate for y prime before I take the derivative again. So if I isolate for y prime, I need to divide both sides by x plus 2y, divide both sides by x plus 2y, and that means my y prime is really equal to 2x minus y all divided by x plus 2y. And you might be asking, well, why'd you do that? You have to use quotient rule now instead of product rule. And well, you're right. Maybe you prefer it that way. You could just take the derivative. You either have to use one or the other. I just randomly decided to use quotient rule, which is low d high minus high d low all over low or low squared. So my low in this case is x plus 2y. My derivative of the top is a little bit hard. It's going to be 2 minus y prime, and that's going to be subtracting. I'm running out of room here. I'm going to move, I want to move more than just you. There you go. Move all this to the left here. Sure, right there is fine. And I need to do high, which is 2x minus y times the derivative of the bottom. So the derivative of the bottom, I have 1 for the derivative of x. The derivative of 2y is just 2y prime. All right, that's all going to be divided by LOLO, which is x plus 2y quantity squared. All right, so, oh, I totally didn't even see it. We had points to plug in, which means I could have made this a lot more simple. Actually, no, I had to do this anyway, but I can now plug in up here. Let me move you out of the way. I'm going to move you, sure, right there. This now becomes, if I plug in the x-coordinate 3 and the y-coordinate 0, it's going to be 2 times 3 minus 0, all divided by 3 plus 2 times 0, which is 6 over 3, which is 2. So everywhere where you see a y prime now, that is 2, because y prime is equal to 2. All right, so I keep moving things, and I don't really apologize because it's not that bad for writing things everywhere. It's just it's not very neat. All right, so plugging things in. X is 3, so I have 3 plus 2 times 0, and all this is in parentheses, by the way. 3 plus 0 times 2 minus 2, because 2 is our y prime, and that's all going to be subtracting 2 times 3, which I guess I could have just written as 6 minus 0. That times 1 plus, I'll just change that to a 4 right now. And then on the bottom I have 3 plus 0 quantity squared. Okay, what is all this if I simplify? So 3 times 0, that's all gone. 6 times 5, that seems to be 30. On the top and on the bottom I have 3 squared, which is 9. Divide the top and bottom by 3, I get 10 thirds. Correct answer is D, 10 thirds. Alright, so second derivative is equal to this, and I'm looking for inflection points, so you guys know this one. You've seen this before. F double prime, the definition, oh, sorry, I'm going too fast. F inflection point, there we go. The definition of that is where F double prime has a sign change. Sign change means that when I have it in factored form, I have an odd power. So I'll write that underneath here as well in case you forgot. That's an odd power when I have it in factored form. This is in factored form. This has an odd power. This has an odd power. This has an even power, which means this will not give us an inflection point. The only inflection points are at this, which is 0, and this, which is -1. So 0 and -1 only is the correct answer, C. And our final problem, the line is tangent in the first quadrant. Then, oh, this guy's going to be fun. Okay, so essentially, we've only done one problem like this in the whole pretest, which is interesting. I think we might have 2 of these in the actual test. Not quite sure. But let's go ahead and take the derivative of this, start plugging in things. So this is where you go tangent first. So I'll just say tangent first. So whenever I'm working on the tangent, I have 3 minus 4y prime is equal to 0, which means my y prime here is equal to, it's going to be a -3 on the other side, and then it's going to be 3/4 because divided by a negative. Okay, and then I'm going to do curve. So the curve is y prime is equal to 3x squared, just 3x squared because the derivative of a constant is just nothing. So y prime is equal to 3x squared, and I know what y prime is. Y prime is 3/4, so I can plug that in. So I'm plugging in now. 3/4 is now equal to 3x squared. Divide both sides by 3, and I know I'm running out of room here. I have 1/4 is now equal to x squared, which means x is equal to plus or minus 1/2. I know if it's going to be positive because it tells me I'm in the first quadrant. When I'm in the first quadrant, that's this quadrant, that means I have positive values of x. So which values of x should I use? Positive values of x. So I come back over here and I say, okay, it's just the positive one. Okay, go back to your tangent function. So tangent function. We know that my tangent function has x equals 1/2, so I can say 3 times the 1/2 that I just found before, and I still need to fill in the rest of the equation, so minus, sorry, this one up here, minus 4y. So minus 4y is equal to 0. I'm trying to find my y coordinate from doing all this work, and I'm realizing I'm running out of room, so I'm going to move this guy, all of this guy, get the 2 as well, over to the right a little bit more. And I have 3 halves. I'm going to move that over to the right-hand side, so I'm going to have negative 3 halves is equal to negative 4y, which means my y is equal to, divide both sides by negative 4, and I'm going to get a positive 3/8. All right, and then finally going back into the curve to solve for k. I have my y, I have my x, I don't have my k. My y I just found was 3/8. My x I just found over here is 1/2. That's going to be to the power of 3, and that's going to be plus k. All right, 1/2 to the power of 3 is just 1/8, so this now becomes 1/8 plus k is equal to 3/8. And if I subtract 1/8 k, I'm left with 2/8, which is equal to 1/4, which is the value of k. Correct answer is B. All right, that concludes this video.